Hello everyone, thank you for joining. My name is Tija Bizada. I'm the product lead of Sysrev, and today we're going to be talking about the auto-labeler. Quick agenda for you before we get started. Have some quick updates regarding Sysrev on the whole, but we'll be spending most of our time exploring the auto-labeler today. Brief overview of the feature and how it works, some of the nuances of the auto-labeler and best practices, and use cases. Well, what's it actually for? But first, again, some quick updates. Last Monday, we gave a presentation at the Ecological Society of America's annual meeting. If you are interested in seeing those slides, they are available at this link. You can either follow the link or use the QR code. Second, our next webinar will be titled Sysrev in the Classroom. As we all kind of intuitively know, if not very really know, students are facing ever-growing challenges making sure that they actually learn scientific reading skills, the ability to read articles, evaluate them based off of some criteria, and then extract the data that they need. At the end of the day, they probably just try to ask ChatGPT or one of the other LLMs what the answer is. By having systematic review or scoping review projects as classroom projects, you really nearly force, and really enable them to develop these skills with real use cases. And so tentatively scheduled for Tuesday, September 30th, Sarah Young, who is a social sciences librarian at Carnegie Mellon, who has an institution-wide license to Sysrev. They use it for true research projects as well as classroom projects. Will be diving into Sysrev in the classroom. Some exciting news, upcoming features, probably our most requested feature, filtered review. And so for those of you familiar with Sysrev, you're probably quite aware that we have a fairly robust filtering system allowing you to filter on sources, on labels, on predictions, even on the auto-labeler, which we'll be discussing today. Now with filtered review, you'll be able to review just those documents that match that filter, make it a lot easier to leverage the auto-labeler, only screen the things that are actually relevant to you. Also help you with perhaps assignments or giving up work if particular folks are focused on just particular sources. So that's coming later this week. Really excited about that. And then we're launching a new integration. We'll be supporting the Gemini large language model. To be clear, this does not replace GPT-4o, which is our current integration. Rather, it will be another arrow in your quiver. It is generally our philosophy that there's no best way, no right way to do research. Rather, we want to give you the tools to allow you to make those decisions for each project, for your own research based on your own needs. Now, as you can see up top, I have a number of tabs open. This will mostly be an in-app webinar, but wanted to quickly go through some slides that on a high level really address what I hope your takeaways from today are. If you were going to leave this webinar with just a few learnings, they're probably contained on this slide, albeit the actual in-app demonstration will really showcase what it is that I'm talking about. So first is that Sysrev now can be quite the exploratory research tool, particularly with the auto-labeler. The idea that you can upload hundreds if not thousands of articles, ask the auto-labeler to detail them. What's the content? What are the topics? What were the methods? Now there is a way to sort your articles without needing to review them. Depending on your use case, obviously you may still want to have a human review them or check the LLM. But again, this is a way to drastically increase the amount of information that you can consider. And to really put a nail on that, here's a real life example of a series of projects done by an organization who uses Sysrev for contract research. And what you can see on the left is that they uploaded nearly 45,000 articles. Now, it doesn't matter if you have 50 PhDs and nearly 2 years worth of time, 45,000 articles is a lot of articles to review. But by asking just two simple questions, having two labels that the auto-labeler fills out, they were able to get that down to 366. First, they asked, does this deal with the specific chemical that they were interested in? And then they asked, does this deal with the specific toxicity that they were interested in? And again, that's a 0.1, less than 0.1% of the articles that they uploaded are now on their I need to review these list. Again, depending on your use case, perhaps you're not comfortable having an LLM remove again over 99% of the articles. But if your goal is to get a high level kind of understanding, maybe some broad strokes, or to just really hit on the most important articles, the most important pieces of data, it doesn't matter if you're 100% complete, this can be quite the tool. It also allows you to not have to spend so much time focused on that search methodology. What is the exact combination of terms that gets all of the potential articles but doesn't leave any out? Now you can cast a wide net, and using the auto-labeler, help yourself narrow down and find just the articles most likely to be relevant. One more piece here, and we'll kind of go into this, but in this example, they asked the Boolean question, the yes, no, true, false question. Does this article deal with their specific toxicity? Had they instead asked which toxicity is discussed and perhaps use a categorical label, now they would be able to use the exact same auto-label run, the exact same process to do other types of downstream research. Maybe in week 1, they're interested in toxicity 1, but in week 3 or 4, they'll be interested in a different type of toxicity or a different mechanism, right? And so again, having the auto-labeler quickly sort, first label, but then allow you to sort through your articles can be quite powerful. Now, anyone who's familiar with Sysrev understands how useful it is as a data standardization tool. For those of you who don't know us, InSilica is a company that has developed, continues to develop and maintain Sysrev, and we got our start in cheminformatics. And one of the biggest pieces of building a predictive model at the time for toxicity is having a database that you can use to train your model. One of the most excruciating pieces, at least in my mind, of building out that database is making that spreadsheet rather, clean enough that you can actually use it, right? Anytime that there's any variation in a string, I say human, you say Homo sapien. I say rat, you say Wistar rat. Now that's something where after the fact, someone needs to go through that spreadsheet, find all the slight variations, potential misspellings within a single quote, same answer, right, human, Homo sapien, and standardize them so that the model can actually be trained, can actually be run. By using Sysrev, you mandate that standardization as you extract the data, saving yourself time. Take that a step further, and we actually allow for the standardized extraction of full tables, right? So often, or very often, articles will have multiple sets of information that can't be reduced to just one piece of information. Intervention 1 had outcome 1. Intervention 2 had outcome 2. Sure, you could have 2 sets of 2 labels, 4 labels, but what happens when there's intervention 3? Or intervention 1, outcome 1, population 1, intervention 1, population 2, outcome 2. It starts to grow geometrically. And so by having what we call group labels, basically tabular labels, you again force that standardization of the data as it's being extracted. And that brings us to today, where we take it one step further, and now AI is actually able to extract the information in a tabular format. And what's amazing here, and we'll get into this a little bit more, is that by having a group label, the LLM actually considers the whole set. And so it's extremely and quite impressively accurate when pulling out these pieces of information. In fact, it may, depending on how you set up your labels, even find mistakes in your source document. Again, we'll go into detail for this specific example. But as we said, we don't believe that there's any one right way to do research, one correct way to do research. And depending on your use case, depending on your own confidence or comfort with using an LLM, you may still want to have a human check that. And so we have tools built in that allow for human in the loop interactions, and then it really becomes more of a QCing of the LLM generated data as opposed to just blindly trusting. So that brings me to the end of the slides. Now we'll jump into the application, but again, I hope that kind of frames the conversation, what you're about to see, and helps you kind of with those high-level takeaways. Okay, so let's get into Sysrev. So the first project that we'll be using in this webinar is called Reviewing Reviews Demo. And so in this particular project, I've uploaded 3,500 articles, and my search on PubMed was simply for systematic review and machine learning. Now what I'm looking for here are articles that explore how machine learning affects systematic reviews. And to that end, I've created two labels. My first label is the article a study about the application of machine learning in systematic review methodologies. Exclude studies that are a systematic review and not about systematic review methods. Now you may be wondering, why did I phrase it quite like that? And the answer is, the description for your labels is actually the prompt used by the LLM. So for any of you who are familiar or maybe use LLMs in your own day-to-day, the prompt is basically your question or your statement or your request. It is the piece of text that is considered by the LLM when it generates an answer. Prompts can be quite complex these days. Give it enough detail, certain LLMs can generate a prototype for you or generate a whole presentation for you. In this particular case, we're just trying to give enough information to the LLM that it can answer my question. Is this about using machine learning in systematic reviews? And please do not include things that are simply systematic reviews and not studies about systematic review methodologies. Let's go into some of the settings that you see here. First one that you're going to run across is require answer. Again, those of you familiar with Sysrev, having required answer turn on during a human review means that I must answer that question before I can press save, right? And so here I've answered one, still can't press save. Here I've answered two, still can't press save. Once you've answered all three, you're now able to save that article and move on. For the LLM, it works the exact same way. And so if there's a particular label that you want the LLM to answer no matter what, require the answer. If you don't have that toggle turned on, depending on the LLM's own confidence with its answer, it may or may not answer that. And so again, very important. And then on the right, we're going to see enable auto extraction. This is the core of the auto-labeler functionality. When this toggle is turned on and you process an auto-labeler run, it will consider, query, and answer this label. When this toggle is turned off, then if you process an auto-labeler run, it will not consider, query, and return an answer for this label. And so long story short, if you want a label answered by the auto-labeler, turn it on. Use full text is exactly what it sounds like. So if you've uploaded a PDF or PDFs with your title abstract or other metadata, if you've uploaded JSON, same answer. If you click use full text, then the LLM will indeed consider the full document when generating its answer. If you have not uploaded full text, turn it off, right? Two quick notes. One is that as of today, the LLM will only consider the first PDF that is uploaded for any one article, and also it will only consider the first 50 pages of that PDF. If you have a specific use case where you need to consider multiple PDFs or have really big documents that are greater than 50 pages, just reach out to us. There are ways and tools that we have to enable that, but for your out-of-the-box sysrev.com day-to-day use, again, just one PDF per article and just 50 pages per PDF. Last but not least, reasoning with confidence. And so turning this toggle on does two things. We'll explore one of them in more detail later in this webinar. The first thing that it does is it asks the LLM to include a confidence score with its prediction. The fire truck is red and I'm 90% sure. The taxi cab is yellow, but I'm only 10% sure, right? These are very, very different answers, and you may or may not want to trust an answer given the LLM's own confidence. The second thing that it does is inject something called a chain of thought, a series of questions into the prompt. Again, that gets a little nuanced. We'll go into that in more detail later. And so now if we go back to the articles, we can do a few interesting things. First, I can see how many articles have been labeled, are they about systematic reviews? And it looks like right now I've labeled 110 that are about systematic reviews. Or I'm sorry, 110 have had the question, is this about systematic reviews, answered by the auto-labeler. Conversely, only 100 have had the second question answered. Second question being, is this study about biomedical or human health studies? Again, our goal here is to see how machine learning has been used to help in biomedical focused systematic reviews. So it can tell me whether or not the auto-labeler has answered it. It can also tell me the answer for that article. So out of 100 articles queried, 97 deal with biomedical sciences. So on the one hand, this is useful information, but if the goal was to help me quickly find only the relevant articles, perhaps not the most useful. Again, if we go back to that slide that I showed you earlier, this isn't the biggest reduction in number of articles that you'd have to consider. It's only removed 3. Conversely, if we ask, well, how many of these are about systematic review methodologies? Well, now it's 40 of the 110. And so if it's 40 of 110, then it would be plus or minus 1,000, a little bit more, of the 3,000 articles that we've uploaded deal with systematic review methodologies. And so again, while it's not quite the 100% to 0.1% reduction, this still is a 2/3 reduction in the number of articles that you would need to consider were you actually doing this review. How does that actually work? And so the next thing that I would like to do is exclude any article that's been labeled by the auto-labeler. And then I'm going to ask it the same questions. Now, when I think about my labels, if my goal is to reduce the number of articles that I need to manually screen, then this biomedical question doesn't really help me. It only reduced it from 100 to 97. And so I'm going to turn that off. And so what this little robot does is the same thing as this enable auto extraction toggle. And so it allows you to quickly change which articles are being processed by the labels. If you get to the point where you are happy with a particular label, but you want to keep tinkering with some others, just turn off that label by NAT for a little bit. It doesn't remove the answer. It doesn't remove the answer from being shown. It just means that the auto-labeler will not consider that label during its next run. But I do want to ask this question about systematic reviews. This reduced me from 110 articles to 40 articles. This is a pretty good filter. So if I go back to my articles, and let's actually take this off for a moment. And so let's say that I wanted to review 110 articles. As you may notice, you see the word available funds, you see articles, and you see cost. And so the auto-labeler does cost money. It is mostly a pass-through plus some processing. Basically, our charge from the LLM, we just pass that through to you. Before we process any labels, any articles, before we query the LLM, we calculate the cost of what that particular processing will be. And so in this particular case, though, you may be wondering, so why is it cost 0? Well, that's because these articles have already been reviewed by the auto-labeler, and so there's nothing for it to do. And we're never going to charge you to run the same label on the same article that hasn't, again, if you add a new category, it's effectively a new label. You could run that again. But here I haven't changed the label. It's the same articles. And so there's no cost because there's no need to actually run it. Now, the moment that I exclude the articles that have been labeled, well, now that changes the calculus. And so for 110 articles, for one label, the cost is roughly 57 cents. But just to show you what it looks like, let's take that down to 10 labels. I'm going to run the auto-labeler. It's going to process. And so what's happening is it's, again, looking at all the articles that have been chosen, looking at the labels that are turned on for auto-labeler, querying, in this case, GPT-4o, and returning that information to us. And so sure enough, now we can see its answer. And is this article about systematic review methodologies? No. This is a systematic review of using machine learning to calculate breast cancer risk. False. And so that's a quick, what are the nuts and bolts of using the auto-labeler, at least for Boolean articles. Our next example will continue to build this out. So in this particular project, I queried PubMed for TSCA, the Toxic Substance Control Act, and my goal was to learn about what sort of articles we have, what information is contained in these articles. And so what I've done is I've created a series of labels, and to kind of showcase the difference, I've made two versions of each label. I've made a categorical version and a string version. So let's take the chemical. In the categorical version of which chemical is referenced in this document label, I've very explicitly written the 14 chemical names that were included in the original TSCA regulation. And so when the auto-labeler looks at or considers this label, it's only going to choose one of these options. You'll also notice that I have an other and a none. Particularly when you require an answer and you're using a categorical, we highly recommend that you include an other or a null or a not specified option, because if you force an answer and it's a list without one of those options, then the LLM is going to choose one of the options. That's what it's been programmed to do. And so even if this article was about benzene, benzene's not on this list, but if it's requiring an answer and it has to choose from one of these options, it will. And so again, if requiring a categorical answer, we highly recommend that you also include none, other, not specified, or even a combination of all three. So conversely, for the string version, I don't have those options. All I ask is what chemical is referenced in this document. Nice open-ended question. And the results that we get are telling and really make sense when you intuitively think about what those two different questions, processes, queries look like and how they would be perceived by the LLM. So here's an article that explores mutagenicity of 1,2-dichloroethane on salmonella. Let's go through the different labels and see how they differ. So first for the chemical. It correctly identified, and albeit this is an exact string match, it correctly identified that this article is about 1,2-dichloroethane. When it read this article, it identified all of the chemicals, checked that against the list of possibilities, and there was only one overlap. So there it is. What's equally interesting is when you ask the open-ended string question, which chemicals are in this document, it identified, well, all the other chemicals. These chemicals are indeed mentioned in this document, and they weren't just pure catalysts or study materials. Rather, this article even examined how these chemicals affect the mutagenicity of dichloroethane. And so if you're asking what chemical is studied in this article, well, it turns out there are actually many. For the CAS number, when given a list of the CASs that are associated with this chemical, it correctly identified that this chemical is CAS 107062. It should be noted that there is no CAS explicitly written in this document. However, the LLM is able to consider its options. And so when you give it options within a category, it internalizes those and considers everything that it knows about them. And what it knows about CAS 107062 when it checks its own vast training data and logic is that that CAS is associated with 1,2-dichloroethane, and this article is about 1,2-dichloroethane. And so this article is about that CAS. Now again, alternatively, when it's just an open-ended string, it doesn't think to itself, what are all of the CAS numbers and what are the chemicals associated with that CAS number? That's way too large of a internal query, too much to process. And so it just looks at the article, says there are no CASs explicitly mentioned here, and so its return is null, right? I don't see any CASs here. For toxicity, it identified the same thing, whether it was a categorical or a string, albeit this is a relatively straightforward article with respect to toxicity. But again, once we get to species, we see a little bit of difference. And so if we look at my categorical label for species, I don't have salmonella as one of the options. I have bacteria. But the LLM is able to rationalize through that. This article is about salmonella. Salmonella is a bacteria. Bacteria is one of the options I'm allowed to choose from. Therefore, this article is about bacteria. Again, alternatively, when asked a string, Well, it's going to give the answer that it thinks is most accurate, which in this case is salmonella. Depending on your use case, really again tells you what kind of answer, what kind of label, or what options in the label you really want here, right? If your goal is to do a meta-analysis of all the bacterial studies, well, then you probably want bacteria as your category. If your goal is to just pull out as precise of a species as possible, then maybe you ask the string. If your goal is to do some follow-up studies on just articles dealing with salmonella, maybe you would have wanted to have salmonella be one of your categorical options. As you'll notice in the next two labels, because while having a string can allow for precision, it does also allow for variability. This goes back to what I was talking about earlier. I say human, you say Homo sapien, I say rat, you say Wistar rat. In this particular example, we asked, well, what type of study does this document describe? And when given a categorical, well, in vitro was the option that I gave it. But when left to its own devices, it says in vitro study. This is something we actually see quite common, where depending on whether or not the abstract, the article itself calls itself a systematic review or a systematic literature review, a string that asks what type of study will pull out that variation. That just means that at the end of the day, someone needs to go through that spreadsheet, find all the times that it says systematic review or systematic literature review, and equate those two pieces of data. So again, there's pros and cons for string versus categorical when it comes to that post-extraction analysis, and it really comes down to how you want to analyze the data, which one makes the most sense at the time. Now, we had mentioned confidence with reasoning before, that it includes a confidence interval with its with the result. And let's explore the other thing that it does, which is inject a chain of thought series of questions. And so first, let me just point out that right now the species the categorical species label answer is bacteria. If we again look at that label, we'll notice that I have reasoning with confidence turned on. But now let's quickly turn that off. So we're going to turn it off, we're going to save the setting, and then because I only want to process this one article, we'll grab its identifier from the URL, filter on that identifier. That means that I've just got one article, and now I can run the auto-labeler. And so right now it's just running that slightly adapted, slightly changed label on the exact same article. And lo and behold, now it says rat. Now why does it say rat? That's actually quite interesting, because if you control F for rat, nowhere in this title and abstract does it actually mention rat. And the answer is actually this denatured S9 fraction. For any of the biologists or associated sciences folk in the audience, denatured S9 fractions come from rat livers. And so the LLM is able to read this text, understand that this particular string of entities, string of words, is something that is actually associated with rat livers. And rat is one of the species that it's supposed to consider, and so it's including rat in its answer. Let's go back and turn that back on, and its reasoning, its explanation of itself will actually explain what's happening here. So we'll go back to the article list, we'll process it one more time, and then we'll see what it has to say. No rat. And so this might be too small for you to read, so I'll read it out loud. Despite mentions that might hint at indirect involvement of rat liver fractions, these do not detract from the central bacterial investigative theme of the article, which is a very verbose way for the LLM to basically say, yes, this study used rat livers, but they used rat livers to test on salmonella. This is an article about the effects of a chemical on salmonella, not an article about the effects of the chemical on rat livers. And so, again, by introducing what we call chain of thought, you force the LLM to explain itself, to think through its answer, and it can really change the final result. And so if you would like to learn more about how Sysrev uses chain of thought, I highly recommend you go to help.sysrev.com, where we have an article exactly about this topic. It links to a chain of thought publication, really explains kind of the rationale and philosophy behind chain of thought, but also explicitly lists our chain of thought questions. And so basically by turning on reasoning with confidence, what we're doing is interjecting these 9 questions into the LLM prompt. And by doing so, it forces itself to reason through its answer and make sure that it is rationally and logically consistent with the question being asked. Now this can kind of cut both ways. And so here's an article or a project also dealing with Tosca, but the thing that is different is that in this particular case, I've queried OpenAlex. And for those of you who don't know, OpenAlex is a research database, all open access, actually quite open in nearly every way. It's a lovely tool. However, it contains a lot of gray literature. And while there are many pros with gray literature, the biggest con tends to be that it doesn't contain abstracts, or doesn't always contain abstracts. And sure enough, if I skip through these articles, I probably won't find one with an abstract. Now, if I go and I look at my first article, you'll see that I've created an auto label that asks, well, is there an abstract, right? If you're querying OpenAlex and you only want to review things that I was able to pull abstracts for, it's a pretty good use of the auto labeler. Which articles of all of these that I uploaded actually have an abstract that I can review? Does this have an abstract? Now you'll notice that it says true. Now why does it say true? Well, it says true because, and again I'm reading, despite the metadata not explicitly stating an abstract, it is a typical component of all scientific articles to provide a concise summary of the study. Therefore, it is highly likely that the article contains an abstract. Again, a very verbose way for the LLM to basically say, well, this is a research publication and research publications have abstracts, so this probably has an abstract. And don't get me wrong, I have no doubt that if I were to go to this DOI, this article does indeed have an abstract. That's not really the question that I was trying to ask, right? I was trying to ask, does this have an abstract for me to review? But what's interesting about this, if I turn reasoning with confidence off, go back, articles, refresh so that the auto labeler refreshes, and click 1. It's actually a good time to mention how the auto labeler processes. So it does listen to all of your filters, and it processes the number of articles based on the order that they are shown. And so were I to put 10, it would process the first 10 articles as visualized on this page. Were I to put 300, it would process the first 300 of this list of 525. But so let's run the auto labeler. Go back to that same article, false. So when it's not asked to reason with itself, it's not going to come to the conclusion that this is a research publication. All research publications have abstracts and therefore this has an abstract. It's just going to answer false. And so this really speaks to how the prompt itself can really affect the answer. So let's turn reasoning with confidence back on. And let's also turn this article back on, or this label back on. So enable it, unhide it, save my settings. Slightly different question. Let's go back one more time just so I can actually read it. Very simple. Does this article contain an abstract? That is different than, does the uploaded article contain an abstract that was explicitly uploaded with and or included in the metadata? This is a much more clear question. It speaks more truly to what I'm actually asking. I'm not asking if this publication has an abstract anywhere. I'm asking if there's one that I can look at within Sysrev.com. So even with reasoning with confidence turned on, again, go back to the articles, process one more time. Now I'm asking it to process 2 labels. You will note that anytime you turn on the full text toggle or you turn on the reasoning with confidence toggle, the processing can take a little bit more time. But again, the query that you're actually passing through to the LLM is a little bit more complicated. And so that's not very surprising. Go back to this article. And again, now that I've turned that reasoning confidence on, it's coming to the same answer that it did before. This is a publication. All publications have abstracts, therefore this has an abstract. Whereas the more explicitly written question, is an abstract included in the metadata that was uploaded with this article? Well, the answer is false. In fact, it even says normally abstracts are included in metadata, and thus the absence here indicates that it was not explicitly included. And so again, just a slight variation in the prompt really matters in how the LLM considers the question. And so this is something to keep in mind as you explore whether or not the auto-labeler suits your purpose. And so one thing that I've kind of mentioned a few times now is that it sure is nice to try out the auto-labeler, run a few articles, see how it performs, and then adjust if necessary. We have some tools that make that process a little bit easier. For that, let's go to our next project. And so here's a project on wildfires. It largely just serves as a demo project. You'll see that we've invited a number of folk have labeled articles. However, if I go to the articles page and I ask, match the articles that the auto-labeler has answered at all, we'll see that the auto-labeler has labeled 32 of these articles. Now, the moment that you have an article that has been labeled by both the auto-labeler and by humans, a new report appears on the overview dashboard, and that new report is the auto-label report. What this does is it compares the auto-label's answer with the answers extracted or labeled by your human reviewers. Very important, obvious, but very important note here is that this report assumes that your humans are correct. And so when using this report to gauge the accuracy of the auto-labeler, it is very important that your human answers are correct, and probably worth double, if not triple checking and really validating that they are, because again, if they are the benchmark and the benchmark is wrong, then this report is less than useful. But so what this does is it looks again at all the auto-label answers, all the human answers, and compares them. And so an exact match is what it sounds like. A mismatch is when nothing agrees. A partial match breaks down like this. Categorical labels are partial matches if at least one of the chosen options overlaps. So if I say red and the auto-labeler says red and green, that's a partial match. If I say red and blue and the auto-labeler says red and green, that's a partial match. A string label is a partial match if at least one entity, for most practical cases, word overlaps, or one option, if it's giving multiple answers, overlaps, then that's a partial match. And group labels, where at least one row is consistent across the entire row, we'll call that a partial match. And so what this does is it, again, goes through for each label and sees where the auto-labeler and your humans disagree. And so what we consider best practice, or perhaps better practice, it's something that we do quite often when we're using the auto-labeler in our own research, is we'll have humans review 10 to 20, and we'll have the auto-labeler review 10 to 20. Let's take 20. If the auto-labeler agrees on 18, 19, 20, well, you can probably use that on the rest of your corpus. Again, that wiggle room really depends on your use case. Do you need to be 100% accurate, or do you need to just capture most of the information that is relevant to you? Conversely, do you just want to mostly reduce the noise, but if there are a few false positives, you're okay with that? You'd rather be more inclusive than not. Again, how you structure your research, which things are most important to you for a given project, we leave to you. We're just trying to give you the tools so that you can make informed decisions. Conversely, if humans answer 20 and the auto-labeler answers the same 20 and it only agrees on 2, 3, or 4, well, that's where I would say, either review your prompt, perhaps even reconsider which type of label you're using. Also, don't not consider talking to your human reviewers. There have been many times where we've used the auto-labeler, we've come to different conclusions, and then we realized, while doing our own review, we skimmed a sentence that actually had a really important piece of information or detail, nuance that actually, the auto-labeler was right and we weren't. I'd like to say that's relatively uncommon, but probably at least once a project, we find something where we disagree and it turns out the auto-labeler was right, but it's because, its eyes don't get tired. It doesn't skim particular sentence is. It truly is taking into account all of the information that it has available to it. And so that really, again, brings me to the end of, now we've covered Boolean labels, string labels, categorical labels, reasoning with confidence, and how it can affect the answers that you get. Now let's take this a little bit further and really talk about tabular extraction. So this is a project where I have uploaded SDSs, safety data sheets. This is pretty similar to one of our main uses, one of the reasons that we even developed this tool. And so here again, multiple sets of data. I have 5 DRAISE tests, a number of inhalation tests. They each have their own dose. They each have their own result. And me as a modeler, I need all of this information in order to have as much data as I can to train my model. And so what I've done is created 2 versions of the same label. I have a group label where all of the individual labels are categorical, and I have a group label where all of the individual labels are string. So let's take a closer look at these. So test type. Which test is described? I have inhalation, oral, skin, and DRAISE. As you can see, I've very much tailored the given categories to the document that I'm looking at. This is good in that I've captured everything here. This is bad in if there was another SCS that had a different type of test, perhaps I wouldn't be able to capture that. I don't have a not specified or an other here, I just have a null. And so again, I've maybe trapped myself in what information can be extracted. I have species. Which species is the subject of the test? Again, I have the options that you see here. For target, LC50, LD50, I, null, and skin. Dose amount, generally speaking, I like to keep my numeric doses and my unit of said dose separate, although there are pros and cons to that approach, and I'll show you a different example later where I did it the exact other way. But so this is my one string, what numerical dose is described, as opposed to what unit describes the dose, and here I have a number of different units. Again, particularly with units, you really want to standardize, you really want to make sure that there are no mistakes. And finally, the result, how severe was the reaction? Conversely, my string label, I don't give it that much information. I did say in section 11, toxicological information, because I wanted to aim it at this particular section, which type of data, or for which type of test is data presented, but then it's pretty general. What's the species? What type of data? I do give examples within the description. This can be very helpful in pointing your test at the right piece of information, or rather conveying which pieces of information you would like to be extracted, which dose, what's the unit, and again, what was the result? How severe was the reaction? When I look at the results, it's quite impressive. And so for the categorical, it was actually able to pull out all of the information. I will say, if I took this exact label as constructed and again ran it on a different SCS, it might struggle a bit, because if there's a test that's not included here, or perhaps a guinea pig experiment, it wouldn't be able to extract that information because I don't have guinea pig as one of my options. But again, it was able to identify all of the data that we wanted it to. Conversely, when my group label was string, it actually missed the DRAISE tests. Now, I could probably go back to that test type, and I could probably say examples include inhalation, oral, skin, DRAISE tests, and it might perform better. But what's also interesting about this string extraction is that it caught an error. And so perhaps you've noticed by now, perhaps you've not, these units and this unit are all given in mg per volume, mg per kg. This particular piece of data is given in gm per m cubed for volume. Now, it might be that this is right, that this was supposed to be grams per volume. However, intuitively, I think probably not. I think this is actually probably a typo that was included in the original SCS and published and has been, published and in the public sphere for at least 5 years, which is when I first created the group labels demo, albeit long before we had the auto-labeler. And sure enough, when asked to answer which unit the dose is with a string, well, it's going to be precise, and it's going to say, well, that line says GM per M3 per 4H, and so I'm going to say GM per M3 for 4H. What's interesting is above in the categorical, it actually flipped it, right? The unit that I made, the categorical option that I made was mg per m3 per 4h, and that's what it said. And so again, just kind of thinking through how string versus categorical can really change the data that's extracted, whether you need to give it a little bit more instruction in that Dre's test is a test that you're interested in, or that if there are typos within the original document, that a string is going to extract that because it just takes the string at face value. And so at this point, you might be saying, well, that was kind of hand wavy. How do I fix this data? Do I have to just export that spreadsheet and go in and find the right line? And the answer is fortunately no. And so we have something, forgive me as I look for my right screen, we have something that we call prefilled answers. And so let me find that same STS quickly. I'll know it because it has a lot of options. And so what prefilled answers does is it takes the auto-labeler labels and it prefills the human review answers with that information. And so here is the categorical label completely filled out by the auto-labeler. But if I needed to go in and it turns out this wasn't about skin, this was about eye, or perhaps one of these units was a little bit off, or it missed the result, and I wanted to say, actually, this was moderate, mild, or severe. Now I'm able to do so. And so extraction then becomes a QC process as opposed to a true extraction process. Depending on what types of data you're reviewing, this can really drastically help. We work with an organization who uses STSs, extracts data from STSs in their normal have a human reviewer find, identify, and extract the information. It usually takes them 6 to 8 minutes per document. As a QC process, it takes less than a minute on average. Yes, they've timed it. And so again, this is just a way to always, if you so choose, have the human be in the loop and have the data be corrected before you're looking at a spreadsheet while you've actually still got the article in front of you. And so that ends kind of my SCS example, but I want to show you one step further how you can really use the auto-labeler to explore what information you can extract and also standardize and generalize your label so that it can work across many documents. And so here we have a project. Actually, we wrote this publication and published it probably about 4 years ago now. And we were exploring how different genetic mutations affected the efficacy of medication for advanced prostate cancer. And so what began as kind of a me being curious project ended up being quite impressive, at least to me, what the auto-labeler is able to do. And so high level, all I was trying to do, figure out, is could the auto-labeler do more quickly and just as accurately the same sort of data extraction that we had done years ago. I will say years ago, it took us probably about a team of 6 reviewers, and it took us a few weeks to really get all the data that we wanted. This was something that I was able to work through in probably about an hour, but I'll take you step by step through what my process was, and hopefully that's illuminating to you. So the first question that I was kind of interested in is like, can I get any information from this document? Now, while what I'm showing you are the graphs, I will say all of the information, or at least most of the information that was extracted, is also in the written text. And so, for example, jumping ahead a little bit, you'll see that this hazard ratio is 0.69. If I were to search this document for 0.69, we'll find that this information, again, was explicitly written in the text as well as in the graphs. That said, not shown here, I was able to get most of this data of the number at risk for olaparib and the control over the different months since randomization, even though that's not really explicitly written in the text itself, it's only included in the graph. And so what I will say is, if the graph contains words and numbers, specific pieces of labeled data, chances are you might be able to grab that with the LLM. Now, if you were to ask me, could it pull out this particular dot? Not today, although we're in talks with some organizations who that's exactly what they do, and we hope to work with them in the future and make that available to our users from within the Sysrev app, just as we have the auto-labeler querying third-party LLMs. We'd have some sort of graph labeler that queried one of these other solutions. But for now, let's focus on what Sysrev can do today. And so the first question that I asked is, all right, can it get me the 6-month survival rate for olaparib at 6 months? And sure enough, 91%, 91%. Now, when I first did this, I wanted to aim it. And so I even asked, according to figure 1. And so it knew that it needed to find figure 1, find the overall survival for cohort A, and give me the percent of patients alive at 6 months. And again, it was able to do so, 91%. The second question I asked is, all right, well, could it pull out the whole hazard ratio? And sure enough, 0.69, 0.5 to 0.97, 0.69, 0.5 to 0.97, 2 for 2. Now, this is something where formatting really mattered, and so I was careful with how I wrote this prompt. What is the numeric plus percent value of the percent of patients alive in cohort A for olaparib at months since randomization equals 6, according to figure 1? Oh, I'm sorry. Let's try that again. What was the hazard ratio for death for cohort A? Please include the numeric value of the ratio, the confidence interval percentage, and the confidence interval range. And so that was my way of telling the LLM exactly what format I wanted the data to be generated in. And that's something that, again, we recommend. If there's a specific format that you require, tell the LLM. By and large, it will understand and it will listen, and you will get the data in the format that you want. Okay, so I was able to pull out one hazard ratio. Could I pull out more? That brought me to hazard ratios. For a given cohort, and I define cohort A and cohort B, what analysis does the hazard ratio describe, and what is the hazard ratio? Okay, cohort A, cohort B, overall survival versus crossover adjusted analysis of overall survival, and it pulled out the hazard ratios. Now, again, I gave it options. Your options for analysis type are overall survival or crossover adjusted analysis of overall survival. So again, I'm doing a fair bit of hand-holding. And at this point, what I'm thinking to myself is, could I generalize this enough that I could throw this at a completely different document and get the right answers? Not every article that we looked at compared overall survivability and had a crossover adjusted analysis of overall survivability. Some looked at outcome ratios for PSA response, prostate-specific antigen. There was a number of different types of data included, types of ratios included in the different articles. And so, okay, if it could do this, again, could I generalize it enough? All right, well, first let's try to do strings. So instead of me telling it overall survivability and crossover adjusted survivability, instead of me telling it exactly which cohorts to be looking for, could it still pull the right data? And two things are interesting here. First, it now pulled out more information. By constraining it to only consider cohort A and cohort B data, I left off, well, what about the overall population? This article does indeed include an analysis of just everybody. It doesn't only give you cohort A or cohort B answers. The second thing here is, now that I haven't told it that I'm only interested in, quote, overall survivability, end quote, or quote, crossover adjusted analysis of overall survival, end quote, I'm getting some slight variations, right? Now, this text does appear in the document, but this isn't the options that I had given it before. On the flip side, now I don't need to tell it, actually we'll hold that point. I introduced an endpoint death, although it turns out this article really was only looking at the endpoint death. But still, I needed, could I pull out more information? And so one last version of this label, we'll jump ahead a little bit. Oh, you also need the intervention, right? So this particular article was comparing olaparib, the intervention, to two controls, enzalutamide or abiraterone. And so again, while this article, I know it's about olaparib, nowhere in this data does it actually tell me which two things it's comparing with this ratio. So first I added some labels to ask what is the intervention, what is the control. But again, let's skip ahead to the ratio as pure string. For which ratio is data presented? Examples include hazard ratios, overall response rates, and PSA response rates. Again, by giving it some examples, you help the LLM contextualize and consider all of the information that it's looking at and potentially pull out more of the information that you're actually interested in. Cohort we've seen. Which cohort does the hazard ratio describe? Analysis type. What analysis type does the ratio describe? The endpoint. Examples include death, PSA 50 response, radiological response, so whether or not you can actually see a difference in imaging. The actual ratio, this is one label that once I got it right, I did not affect. I was very happy with the formatting. What was the medication, as we just discussed? And again, what was the control? And it does really well. Again, now we've got a hazard ratio for cohort A, overall survival, the endpoint is death. Right data comparing olaparib with physician's choice enzalutamide or abiraterone. And so, okay, that felt pretty general. But again, the question was, could I take this to all of the other articles within this particular document? Things that weren't comparing olaparib, weren't only looking at overall survival. And jumping to a spreadsheet, it turns out it could. And so this was something that, again, I was quite impressed with, considering I remember doing the original research and how long this took. But it was even able to compare a study where instead of comparing, instead of it being an A or a B, we were even looking at different dosages. How does the 400 mg cohort or the 300 mg cohort compare in olaparib versus other medications, right? What's the tumor response rate, the PSA response rate, the radiological response? Now, having a string, this means that there's a little bit more standardization to do if I so choose, but again, for a label that I was able to just throw at 12 more PDFs, pretty dense clinical trial publication, this is quite an impressive amount of data that it's able to extract. And were you to go to a particular article and look up one of these hazard ratios, the information is also correct. And so again, while maybe by having generalized strings, you introduce the need for a little bit more standardization, you save yourself a lot of time going and finding those specific pieces of information. You can even do fun things now, like just Control F for 53.6, and it will take you to the CTC conversion rate for the 400 mg cohort, and you can check the rest of that data if you so need. And so again, can be quite powerful in what types of information it's able to pull out even with the auto-labeler. Now again, if you really so choose and you want to say, no, I'd really like to check this, again, prefilled answers, now you have everything that the auto-labeler generated, but you're able to go and affect this if you so need to. Perhaps there was a controlled and you want to add that information. With that, that brings me to the end of this webinar on auto-labeler. I hope it was helpful. I hope it was enlightening and illuminating. Again, there's not necessarily a best way to use these tools as much as they're very powerful and they're very nuanced. But if you have the time and the willingness to explore this little variation versus that little variation, you can end up with things that are quite powerful, and particularly when you need to extract really dense data or explore many, many documents. It's a great tool to help you be more efficient with that research, whether it's just reducing the number of articles you need to consider, helping you review only the articles that you need to consider, or turning your data extraction into a QC process. With that, I really appreciate your time. Thank you for joining.